Global Finance, Lab 2, Monte Carlo simulations using Excel and at-risk to compute foreign exchange transaction risk and cash flow risk. So in this topic, we're going to try to apply interest rate parity to forecast and exchange rate appreciation, and also use unbiased forward rate. We're going to use Bloomberg to get foreign exchange quotes, forwards, volatilities, and interest rates. We're going to compute cash flow risk using Excel, using the CAR formula, and then a simulation. Then use the simulation software to estimate the effects of foreign exchange hedging on FX cash flows. To get started, what you'll first do is go to the Lessons tab in Angel. Under Lab, download the Lab 2 multinat Excel file and the Lab 2 PowerPoint. Then close Angel, launch the PowerPoint file, launch the Excel file, and then go to your desktop, if you're in the trading room, and launch the at-risk icon that looks like this in the top middle of the screen. If you're not at the trading room, you'll need to download the at-risk software. Go to palisades.com at-risk and get the free 15-day trial if you'd like. Otherwise, this has to be completed in the trading room. Once you have the Excel file up, you'll want to launch the at-risk, and what you'll notice then is you have an at-risk toolbar. So at-risk is an add-in to Excel. And the simulation we're going to look at is Multinat Corporation. Multinat is a US-based corporation that produces microprocessor chips in Australia and sells them to Europe. The only source of revenue comes from the sale of chips, which generate euros. They have costs in both dollars and Australian labor costs where the chips are produced. They have MNC has issued euro-denominated debt, which is used to partially hedge the euro revenues. But they're mostly concerned about a rise in the Australian dollar, increasing labor costs in Australia. So let's look at the spreadsheet. So as a financial analyst, you've collected actual expenses for the last 5 years or so through 2011. And you're forecasting 2012. So your forecast for 2012 are chip sales, which you work closely with the marketing department, and you expect to sell 103,944 chips. You expect the average cost from marketing department to be 53.2 euros per chip, which generates 5.5 million euros in revenue. The spot price of the euro is $1.40. You don't have a forecast of the exchange rate for next year, so we'll leave it at 140. So exchanging 5 million euros for at $1.40 next year will give us $7.7 million. We work with supply chain to forecast material cost. So in this example, we have US dollar material cost, and then the production facility in Australia. Supply chain forecast, you'll need 150,000 hours of Australian labor, and the HR department says the average cost of that labor will be 20 Aussies per hour. That'll generate 3 million Australian dollars in costs at a spot price of $99.9 per Aussie. No forecasted appreciation yet. Will generate $3 million in costs. The total US dollar cost, including Aussie labor and US dollar material cost, is then 4 million. Your EBIT before hedging, earnings before interest and tax before hedging, would be your expense and your revenue from above. We have hedging gains or losses, which will be explained later. Then you have EBIT. Your floating rate debt, you have 22 million in euro-denominated debt outstanding. And the reason you did that is you wanted to finance this operation with euro debt to offset some of the euro revenues. You forecast an interest rate next year of 4.5% on the euro-denominated debt, which will generate €1 million in interest. Again, at $1.40 per euro is $1.4 million in interest expense. Earnings before tax of $2.3 million. Effective tax rate of 35% gives you earnings after tax of $1.5 million. You forecast from accounting $140,000 of depreciation, so we add that back. We then subtract CapEx, which you get from manufacturing, and there you have your free cash flows, which are your profits, add back depreciation, and subtract working capital and CapEx. So the first thing we're going to do is try to forecast exchange rates for next year. We'll just assume all the cash flows happen at the end of the year. So we'll go to Bloomberg and first look up the spot prices, and you can see that the euro is selling for about $1.40, like I said, right there. The EUR USD, so that's the dollar price of the euro. And the Australian dollar is selling almost at parity, 9.991. That's the dollar price of the Australian dollar. And we're going to use interest rate parity and unbiased forward rate to get a forecast of exchange rates for next year to get to US dollar costs and revenues. So for the euro, we'll just use interest rate parity. So we'll look at the interest rate on US and German debt. I'm sorry, that's for the Australian dollar. We'll look at the US and Australian interest rates. And for the euro, we'll just do an easier thing. We'll just look at the forward price. We'll use the 1-year forward price as an unbiased predictor of the exchange rate next year. So looking at the Australian dollar, we have the yield curve for the US and Australia. And you see the 1 year in US is about 21 basis points. The 1-year sovereign yield in Australia is 473 basis points. So we'll plug that into our model. So below the pro forma financial statements, we have the US or the Australian interest rate, 0.0473, and the US interest rate, 0.0021. And then we'll forecast the appreciation of the Australian dollar using IRP. If we take the ratio of 1 plus the US interest rate divided by 1 plus the Australian interest rate minus 1, that'll give me a forecast of Australian dollar appreciation. And since the Australian dollar has 432 roughly basis points higher interest rates, we assume they have higher inflation, therefore the Aussie is going to depreciate by 4.3%. Now for the euro, we're going to do something a lot simpler. We're just going to go to Bloomberg and look at the forward price, because that's an unbiased forecast of the exchange rate next year. So using the Bloomberg spot and forward monitor, I see that the spot price of the euro is $1.40.44 with forward points for 1 year delivery of 87 points. I'm just going to use that 87 right there for the 1 year. So I'll go back to my spreadsheet. Spot price 1.0444. Let me make sure that's right. 1.4044. 1.4044. And then the forward points were 87 negative. So I'm going to subtract 0.0087. So I'll take my spot price minus 0.0087. That's the 87 pips. So I have a forward exchange rate forecast of 139. If I take the forward price minus the spot price divided by the spot price, I get negative 62 basis points. So we're forecasting the euro is going to devalue by 62 basis points. So I'm going to actually just type in these two values above. The Aussie is going to depreciate by 432 and the Euro by 62. So this is my Euro appreciation minus 0.0062 and the Aussie minus 0.0432. Let me make sure that's right. 62 and 432. 62 and 432. Okay, now I have a baseline forecast for free cash flows. Given our depreciation of both the Euro and Aussie, I'm forecasting cash flows of $703,000. And that's where a lot of analysis might end. This is called a static or a point estimate of free cash flows. However, we are looking at now trying to figure out, well, I'm worried about the Australian dollar changing because I do not have any kind of hedge on that. So I want to try to look at the variability of the Australian dollar and calculate a cash flow at risk for exposures to the Australian dollar. So I'll come down here, and here's where I want to calculate a cash flow at risk number. So my cash flow at risk, I'm going to use a 1-year cash flow at risk. Our cash flow at risk formula is V, our position in the foreign currency. Z, we're going to do a 95%, so that Z is going to be 1.65. My sigma, I need an annualized volatility of the Aussie. And I'm going to do a 1-year forecast, so my square root of T here is going to be 1, so I can actually just get rid of that. So the biggest uncertainty then is what is the expected volatility of the Australian dollar? Well, I go to Bloomberg, go to WVol, which is the function that gives you the implied volatilities of currencies. Look at the 1-year at the money volatility and look at the Australian dollar. And you can see the 1 year at the money volatility is 16.105%. So I'm going to plug that in, 0.16105. So if the volatility of the Australian dollar is 16% and the exchange rate is 99 cents, I can just take 16% of 99 cents and see that the annualized volatility of the Australian dollar is 16 cents. My Z is the 1.65, but I can get a more precise estimate of that. If I use the Excel function equals norm S inverse, and I put in a 95% confidence interval, there's the 1.65, more precisely 1.645. And now I just need a V. Well, the V is actually up in my spreadsheet. I'm forecasting that I will need to come up with 3.022 million Australian dollars to pay my Australian labor. So that's my V. I'm going to have a payable of 3 million Aussies. And I already have it linked up here in the spreadsheet. So my cash flow at risk number, my pre-tax cash flow at risk is V, 3 million Aussies, times Z, 1.645, times the annual volatility of the Australian dollar, $799,000. So there's a 5% chance that cash flow is going to be $799 less than what I expect. But we're going to also calculate one other thing we haven't done before, and that's an after-tax cash flow at risk. Because if we do show losses, we'll pay less taxes. So if I just take my cash flow at risk and multiply times 1 minus the tax rate, I will get, there's my 35% tax rate, I will get an after-tax cash flow at risk of $519,000. So after taxes, there's a 5% chance I'll have cash flows $519,000 less than my forecast of 703. So that's how we can do cash flow at risk and try to articulate how much we could lose based on our exposure to the Australian dollar, 3 million Aussies, and the volatility of the Aussie, 16 cents, and my time horizon, 1 year, and confidence interval, 95%. Now we're going to do one more thing, and that is run a Monte Carlo simulation and look at all the possible values for free cash flows given the volatility of the Australian dollar. So the general process for doing a Monte Carlo simulation is create a model with a future outcome, that estimates a future outcome. We've done that. That's our future outcome we're forecasting as cash flows. And that model has to have at least one stochastic variable, meaning a variable that has more than one possible outcome that could be described. And that stochastic variable is the volatility of the Australian dollar. We'll then specify a distribution for the stochastic variable, and that is we're going to specify that the appreciation of the Australian dollar is normally distributed, with a mean based on our forecasts and a volatility based on Black-Scholes implied. Then we're going to simulate, say, 10,000 possible appreciations of the Aussie through a Monte Carlo simulation, and that'll generate 10,000 possible cash flows. And then we'll look at the distribution of those cash flows and then try to make some statements about the likelihood of any given level of cash flows. So in at risk, the steps we're going to use are we're going to define the input for at risk, and that input is the appreciation of the Aussie. Give it a distribution, normal, specify the mean and standard deviation. Specify an output, which is the free cash flow. Run the simulation, and then we'll look at the results. So let's go to our model. If we look at our model here, our parameter for our simulation is going to be the appreciation of the Australian dollar. So if you click on this cell, G15, then go to at risk, and then click on define distribution. And then this gives you a number of distributions to pick. Right now we're going to stick with normal distribution and say that changes in the exchange rate are normally distributed. So I can double click on that or click on apply. The distribution puts in the mean, which is the value is in the cell before. But then right here where it says standard deviation, we're going to have to plug in the 16.105%. So I'm going to put 0.16105. Do not put 16.105. So the volatility is 16% with the expected change of negative 4% based on interest rate parity. Okay, so you should make sure these two parameters look like this. The static value is what's sitting in the cell. And then hit OK. Now in at risk, we have to say, well, all right, so when we run the simulation eventually, it's going to generate 10,000 possible appreciations of the Aussie given the normal distribution, and it's going to get 10,000 free cash flow. So we just need to click on the free cash flow, G31, go to at risk, and hit add output. And it picks up the title from free cash flow and 2012. It gives it a name, and just hit OK. Now I should notice that inside cell G31 is now a risk output command, and under G15 there's a risk normal command, and that's what at risk is looking for. So now we can go to at risk. Well, first of all, let me click back here. Let me click on my output one time, my 700,000. Now I'm going to go to at risk, and what I'm going to tell at risk to do is generate 10,000 possible values for the Australian dollar appreciation. I'm going to do one simulation, and I'm going to start simulation. what this graph here is are the 10,000 free cash flow estimates from at risk. So mechanically, here's what's happening. When I hit go, run simulation, at risk generates a random appreciation of the Aussie that has a mean of -4% and a standard deviation of 16. It's going to do that 10,000 times. These are the 10,000 cash flows. So, and these are in millions. So there's a big clumping of about 500,000 to a million. Right? Now the mean is over here. That's the 703,000. That's what we expected, since we specified a symmetric distribution. And you can also see that 5% of the values are below 183,000. 5% of the values are above $1.223 million. So I'll remember those numbers. 703,000 is the mean, 183,000 is the 5% lowest, 1.223 million is the 5% highest. So I'll close that. I'll then go below in my spreadsheet. I'm going to record those values. 703, 183, 1.222 million roughly. And notice the difference between the expected value, 703,000, and the 5% lowest, 183. That difference is $520,000. That is the exact same cash flow at risk we did using the formula. And it should give you the same value because the CAR formula assumes a normal distribution. The only disadvantage of this formula here is you don't get to see the full distribution. So for example, if I go back to my spreadsheet and I click on the output, G31, go back to at risk and click on browse results, I can get back to my graph, and you can see these are all the possible cash flows. So if you want the 1% tail, I can just go in here and click 1%. And you can see the 1% lowest cash flow is negative 0.03 million. The 10% lowest cash flow is 298,000. So this model is a lot nicer, and we can think about all the possible values of cash flows. What's also nice about this model is we can plug in, say, a value here, say 0. And this tells me if you're worried about having negative free cash flows next year, this model tells me there's only a 1.3% chance of having negative cash flows next year. I'm going to click back in there for 5%. And it looks like that's 1.223, so I'll make that change. And you're going to get slightly different numbers while running this, because you're getting 10,000 different random numbers than I am. So you're not going to have the exact same value, but it should be really close. Okay, you should be around 515 to 525,000, depending on when you run this. And if you didn't, try running it again. It should get pretty close to that value. So if I don't hedge, I have expected cash flow of 703, 5% worst case 183, which is 520 less than the mean value. Now the last exercise we're going to do is in the spreadsheet I built in a hedging strategy. That is, if you go to this cell, D54, and you put in 100%, it's going to simulate that you hedge 100% of your Australian dollar costs with a forward contract. So if you come down here under Australian dollar forwards, it's going to assume that you get a long forward to buy all 3,022,000 Aussies. Now if I put in a hedge ratio of 50%, I'm only going to get a long forward on 1.5 Aussies. So I'm going to put 100 back in there. I'm going to use a year-end forward price based on my expected spot price. Remember we said that the spot price is about 99.9 and a 4% devaluation, which will give me a forward price of 95. And then here's the payoff of my forward. It's ST minus F, so it's the forecasted exchange rate minus the forward price times the number of Aussies. Now the forecasted spot price is E59. E59 is right here. That's just a link to the value up here. Okay, so now what's going to happen is now when I rerun at risk, it's going to generate 10,000 Aussie appreciations. So this number then is going to update 10,000 times. Every time there's a new appreciation of the Aussie, I'm going to get a payoff right here on my forward contract. Now right now there's a small amount just due to some rounding. Well, now when I go to at risk and run my simulation, so 10,000, start simulation, I see that the hedging gains and losses show up. And you get this weird distribution. The min is 702, the max is 702, the mean is 702. So every single value of the simulation is 702. And the reason why that's happening is every time you forecast, say, a random number that generates an appreciation of the Aussie. Say you get a random value that has the Aussie appreciating 5%. Well, what's going to happen is the exchange rate is going to be way up. It's going to be about 105, which means you're going to have a lot higher Aussie labor costs here. But then it's going to be directly offset by gains and losses here. So I can just show you this, for example. Like if I were to just type in 105 as a forecasted, I'm sorry, say 5% as a forecasted appreciation of the Aussie. My cost went way up. However, I also have a $281,000 gain in my forward contract. I'm going to get 703. So that's what's going on with the simulation. I'm going to hit undo. All right, so now if I go to my results, for a 100% forward hedge coverage ratio, I get 703. Worst case, 703. Right tail, 703. Every value is 703. So you have no longer cash flow risk because you now have a forward contract to buy all the Aussies at 95 cents roughly, or 95.5. And we'll do one more thing, and I'll let you do the rest. And that is, I'm going to take the forward ratio to 0. I'm going to have an option coverage ratio of 100%. Now what this is going to simulate is down here, I'm going to have a call option on all 3 million Aussies. I then have a Black-Scholes formula, which is down here. So I've programmed the Black-Scholes formula where I have the spot price of the asset, a strike price equal to the forward price, 1 year. I have the the US interest rate, the standard deviation, and under dividends, I put in the Australian interest rate. That tells me that according to Black-Scholes, a value of an Aussie call is going to be 6 cents per Aussie. So it'll cost me 6 cents to buy a call option with a strike of 95.6. Those 3 million calls are going to cost me 183,000. However, now that I have a call option, I now get a payoff. So my payoff is down here, max 0, ST minus the strike. So now when I run a simulation and get 10,000 different Australian dollar appreciations, this hedging gains and losses are going to show the payoffs of the call. Right now it just has the cost of the option. So now when I run it, start simulation, well, first of all, you notice I no longer have a symmetric distribution. That's because every time the Aussie appreciates, the call kicks in and I get to buy the Aussies at 95. So I no longer have a symmetric distribution. Looks like the minimum is I make 583. So that's my worst case. My worst case is the Australian dollar appreciates, I exercise the call, I buy the 3 million Aussies at 95 cents. So the worst case, the 5% lowest is 584. The mean is 710. So 584, 710, and then the 5% highest is 1104. So 584, 1104. 504, and 1104. And I believe that was 709. So there's a small difference in the mean. The worst case is a lot better than not hedging at all. Although if you use a forward contract, it's better because you didn't pay the premiums. That's the difference between these two. You didn't have to pay the premium for the forward contract. However, compared to the forward contract, the option has a lot more upside, because if the Aussie does, say, devalue a lot, you then don't exercise the option, lose the 183, but then you get to buy the Aussies at a below market price, or at a market price of less than 95. So I'll let you fill in the rest of these by doing a hedging strategy of 50% coverage with forwards, no options. Then come down here, 0% with forward, 50% with options, and then a mixed strategy, 50 forward, 50 option. So what that means is you're just going to change this to, say, 50, 0, run the simulation, record the results, change this to 0, 50, 50% options, no forward, and then do 50-50, is half your positions covered with a forward, half your position covered with an option. Run the simulation, fill in this table, and then that's all the data you need to get. The last step is to write a report. The report is simply going to be this table here, so all I want to see is this table in a Word document, and then the rest of the page you can fill up with an essay. And that essay is going to be 1 page in total with the table. So I hand in 1 piece of paper with the table and some text. It'll be due next week, next Wednesday class. And then you're going to write a half-page essay, and this is going to be individual. And that essay is, if you're the CFO of MNC, justify which hedging plan you recommend. No hedging. Forward hedging, you have to specify either 50 or 100. Option hedging, either 50 or 100. Or a mixed strategy, say 50-50. And then also discuss what other factors would influence your decision. So again, it's 1 essay per individual, which is required, 1 page total, including the essay. So that's Lab 2. I'll see you in class.